We've learned that the limit of a function is the number that the y values get close to as the x values get close to a particular number. And we saw in the last section that sometimes we can make a guess about that by just creating a table of values. What we want to do is create a table of x and y values. Remember, f of x is just a fancy name for the y value of my function. Here, I'm going to use this table to guess the limit as x approaches -1 of f of x. So, I've chosen my x values. I sort of put an extra thick bar here because this table comes in two different parts. Here's a sequence of x values that are a little bit smaller than -1. They would be to the left of -1, but I can see they're getting successively closer. This x value is 1/10 to the left. This is 1/100th to the left. And this is, whoops, that was supposed to be -1.001. That is 1/1000th to the left. So there's a pattern in the x values that they are getting closer to -1. If I stopped here, that would be very irresponsible of me because I would only be taking into account what happened on the left side of -1. So I've got a second part in this table. These would be x values that are a little bit bigger than -1. They're to the right of -1. But again, I've created a pattern that they're getting closer and closer and closer to -1. So I'm going to look in the y values and see. I've set it up so that there's a pattern in the x values. Is there a pattern in the y values? If so, I will guess that that's my limit. And then I've got another table over here. We're going to use this table to guess the limit as x approaches 2 of g of x. So here I've got some x values that are smaller than 2 but getting bigger. And here I've got some x values that are bigger than 2 but getting smaller. What I want you to do is just pause the video, take a look at these two tables, and make your own guess for these limits. I will mention there's a good guess to make in both cases. We're never going to be able to know whether our guess is correct or not if this is all the information that we have. Because a table of values is only going to allow us to make a guess. Because the limit is what we would expect as we get arbitrarily close to the x value in question. With both of these tables, I don't get arbitrarily close. The closest I get to my x value is 1/1000th away. And I could create a table of values where I got closer, but with a table of values, I can never get arbitrarily close. I stop at some point, there's a closest point, that's a certain distance from my x value, could have gotten closer. So, all we can do is make a guess, but that's what I'd like you to do. So pause the video, guess the limit for each of these functions. All right, welcome back. That was my very informal way of having you pause the video. Sometimes I'll edit and put some text on to say pause the video. I didn't want to do that here because I wanted you to still be able to see this table of values with the video paused. So if I look here, my x values are getting closer to -1. The y values 4.76, 4.712, 4.7003. These y values here are decreasing, and it kind of looks like they're getting closer to 4.7. Do I see a similar pattern here? Well, these y values are smaller than 4.7, but it does look like they're getting bigger. So I would guess that the limit is 4.7. It does look like that based on this table of values. All right, over here. Here my x values were smaller than 2, but getting closer to 2. 1.2, 1.02, 1.002. Definitely see a pattern there. It looks like those y values are getting closer to 1. With this sequence of x values that are to the right of 2, but getting closer to 2, 2.05, 2.003, 2.0001, I see a pattern here as well. It looks like those y values are getting closer to 2. The problem is the pattern that I see here when my x values are coming in from the left is different from the pattern that I see here when my x values are coming in from the right. Should I guess that the limit is both of those? No. My guess would be that this limit does not exist. That's because the limit, by definition, is unique. It's the value that the function values get close to. It's the unique y value that we expect based on the nearby behavior. Now, I hadn't made a point of explicitly saying that before. So if you thought, oh, maybe it's 1 and 2, that was very reasonable. Okay? But now you know. It's no longer reasonable because that doesn't match with the definition of the limit. The limit, if it exists, is a unique number.